So pleochroism is what we're going to move on to next. That's that property of some minerals when you turn them through 90 degrees to change colour. So this is a part of that staurolite in the last slide here, and the bottom one here is when the staurolite's east-west, if you like. The length of the crystal is east-west or horizontal, and that shows a relatively strong yellowish colour. But then if you turn that crystal through 90 degrees, you can see that it really does look a very definite, matte, uniform grey. And you'll notice that because staurolite has more or less straight extinction here, you can see that those north-south and east-west views in cross-polars both show extinction colours, so the black colour of extinction. So let's look at another pleochroic mineral, glaucophane, and this is a lot easier. To my eyes anyway, these colours are a lot clearer. So you've got some very definite differences in the colours here. You have an A section here, which is a basal section. You can see the cleavages. And that looks to me a kind of purplish colour, lilac I've called it. But you also have longer prism sections, which are a kind of paler blue, more sky blue colour. And then I'd struggle to find another section which is colourless. So some of these grains in here are colourless. And then even more confusingly, the different sections through the mineral will change in different ways. So the A section goes from lilac to colourless, the B section goes from blue to lilac, and the C section kind of goes from colourless to blue. But I couldn't find any decent examples of that in this particular section. And I think that is probably to do with the fact that these amphiboles are aligned as well. So that particular orientation, the C orientation if you like, is very rare in that thin section because of this mineral alignment in this metamorphic rock. We've got one more pleochroic example here. So this is hornblende, which is an amphibole, very common amphibole. And again, that shows this is rather more subtle. It shows three different main colours. There's a kind of what I've called bottle green, which is kind of slightly bluish or greyish green. Then there is a kind of grass green, or more of an olivey green, which is this long crystal here, the prismatic crystal on the right. And then in the middle there's an even more prismatic, longer and thinner crystal, a couple of crystals, which is very, very nearly colourless. It is a kind of, you could call it a straw yellow, it's called sometimes. Sometimes it's a kind of tan or very, very pale brown colour. So those are colours which are typical of hornblende pleochroism. I thought I'd pick some even more subtle examples of pleochroism. This is really just to kind of calibrate your eyes into the subtlety of these colours. So on the left is clinopyroxene, and you might have seen it confidently described as having green and pink pleochroism, and this is the strongest green-pink pleochroism I could find. Those are quite strong colours for clinopyroxene, and it's very, very rare for it to have that strong a colour. But there you can see the lower one is a kind of pinkish, orangey colour maybe, and the one at the top, which has been turned through 90 degrees, is that kind of greenish colour, which again looks basically grey, but to my eyes has a greenish tinge. And that's the real, that's the extent of pleochroism you'll see in clinopyroxene. Many clinopyroxenes you probably won't see any at all. If you were having a degree of pleochroism, you might call it the more the colour changes on rotation, but actually we just call it weak if it's very subtle, or we call it strong pleochroism if it's like biotite, for example, where it's really, really obvious, and you get very strong colour one way and a very weak colour the other way. So on the right hand side I thought I'd show you something which is even more subtle, which is chlorite. So in fact in this slide I'm not even sure what this high relief mineral is. It could be an amphibole possibly, but ignore that if you can and look at the background, look at the ground mass. Now this looks kind of bluish, but chlorite is sort of advertised, if you like, as pale green. But what I hope you can see, the only reason I put this up really, it doesn't matter what colour you see, but I hope you can see the change in colour from this orientation at the top in the ground mass, particularly in the area I'm pointing to this area down in the lower panel. And that's just purely rotating it through 90 degrees. And to my eyes, the lower disc, the ground mass, is paler, very much nearer colourless. And then at the top panel, it has a kind of, well, a stronger colour, whether that's blue or green or a kind of bluey green. That's up to you, really. But it is a very, very subtle change, and it's those changes, again, that you're looking for with pleochroism.